Hi everybody, we're going to do a little video tonight on Module 5, practice problems number 3, 4, and 5. So let's get into it. So number 3 talks about using your Mollier diagram. What is the quality of a saturated mixture at a pressure of 500 psia and an enthalpy of 1115 BTUs per pound mass. So let's find that on here. So it's asking you to find the enthalpy of, because we give you the enthalpy of 1115 BTUs per pound mass. Now enthalpy are these numbers over here on the left of the, right there. So we're going to find the 1115 BTUs per pound mass. And that's right between 1110 and 1120, right there. So we're going to draw that. And we're just going to follow that line all the way across. We're not too worried about where it ends yet. Okay. And then you'll see that it says the quality of a saturated mixture at a pressure of 500 psia at that enthalpy. So now we need to find the pressure lines. So if you look right here is the 500 psia pressure line. So I'm just going to follow that up. So this is 500 psia. So now we've got a point where they cross. And what it says to do is carefully follow that line down and to the, follow that slope down to the right. And what that means is these lines here show you the quality of the steam. And so if you're looking for the quality, you got to follow those lines. And we land right on this line right here. And so we're going to follow that down to the right. Now look at that. We've got a moisture content of 12. And quality equals 100 minus moisture content. So that means 100 minus 12 is 88. And so we have quality equals 88. And that's how we find that on there. Let's take a look at the next one. On number 4, let me clear this. On number 4, it's asking you to, it says a dry saturated steam at 885 psig. So 885 psig. And we have to be careful about that because this Mollier diagram doesn't use PSIG, it uses PSIA. So how do we convert this to PSIA? Well, we had 14.7. And we can round it off a little bit. I mean, when you're dealing with a chart like this. So we'll add 15, and that gives us 900 PSIA. Okay, so we're going to be using 900 PSIA. We want to find that on the saturation curve because it says dry saturated steam. And this red line here is the dry saturated steam line. Like that's 100% quality. That's steam that is 100% quality, no moisture content. And what we're going to do is we're going to find on that red line, we're going to find our 900 PSIA. And I should have brought my glasses here, but it looks like we're looking at that line right there, 900 PSIA. And we can verify that because it's right next to a blue line. And the blue line, if you look all the way up here, says that it's 1,000. So we want the one underneath it, so the 900. And what it's asking for us to do is dry saturated steam that starts at that point goes through a valve which throttles the pressure down to 200 psia. Okay, well, a throttling problem, remember, throttling problems are not work problems. Throttling problems is no work. So it's a constant enthalpy, which means our enthalpy, whatever line we're on here for the enthalpy, which looks about 1195 BTUs per pound mass, right? If I track that all the way over, that's right about where we're at. We're going to keep going to the right. We're going to stay on that line until we cross, and I'm just going to draw it out a little bit, and then I'm going to find the 200-pound line. And so this gives us our point right here. This is where we're at. That's our starting point. So it goes from the steam system at 900 psia, goes through your governor valves and through a throttling problem to 200 pounds. Now we want to follow that down to where it crosses. We want to, okay, so that's the 200-pound line. You'll see, what are we trying to find here? Well, I'm trying to figure out what we're trying to find. Find the enthalpy. So we know the enthalpy is about 1195 BTUs per pound mass. And the quality. Oh, quality. Okay. So now, remember these lines here are our quality lines. So we're right in between the saturation curve and that next line. So we're going to follow that down. And we're right between 0 and 1, which means we're at, if we were on the 1, that would be 99% quality. So we're at 99.5% quality. Okay. Yeah. And then the last problem uses that starting point. The last problem says, let's start there, 200 pounds, 99.5% quality. Find the work done by the turbine if the turbine exhausts to a condenser that's at 23.82 inches of mercury vacuum. Okay, so we know our starting enthalpy, and we know we have our starting point. What we need to know is the final PSIA that we're going down to. So you have to do a conversion. We have to convert 23.82 inches mercury vacuum to PSIA. So let me find some clean space here. And what that means is, actually I go here. Why am I not just writing on this? So 29.92, which is absolute vacuum, right? Minus 23.82, which is what I give you in the problem. That gives us 6.1 inches mercury absolute. Now we have our pressure in absolute instead of relative. That's good. And then if we convert that 6.1 inches mercury absolute, that gives us about 3 PSIA. And I'll let you do the conversion. Make sure you show your work. So yeah, we get about 3 PSIA. So let's go back to our here. Now let's find our 3 PSIA line. And we'll just draw a line on it so we know when to stop. All right. And then a constant entropy process, a work process is a constant entropy process. So we're going to go straight down from that point. We're going to follow our chart down until we get to the 3 PSIA line. And what is it asking for here? Find the work done by the turbine. So now we need to know at what enthalpy does this cross. So let's come back over here and find our enthalpy. And it looks like 920. So we started with 1195 BTUs per pound mass, and we're going down to 920. Well, it's 1195, and we're going down to 920. So we just subtract those, 7, 8. Oops, I did something wrong there. 275 BTUs per pound mass. And you might come up with a little bit of different numbers. Maybe you come up with 280. Maybe you come up with just something a little bit different, but that's fine. When you're working on those charts like that, that's how it comes out. But that's how you're working those. The directions are on the quiz, the steps to follow. So you're really just following those steps, writing where you're at, showing any work you have to do, and that's how you do those questions. All right? I hope that helps. Thank you.